This is a catch-up for the first session of mus132. They're slightly mathematical, but the aims of this module are to look at all manner of software that can help you in the music program. And so what we were looking at was Excel, but to get there, to do something interesting with Excel, we began with thinking about what sound is. And we looked at the circle and how it is divided with a diameter and the ratio of the ratio. Let me just get a text document up here. The ratio of the circumference to the diameter equals pi 3.14, and as the diameter is 2 times the radius would be here, and we're going to trace a radius going around the circle like this. So the radius is 2 times, the diameter is 2 times the radius. We know that the circumference equals 2 times pi times the radius. And if the radius were 1, then c would equal 2 pi. So that's a useful constant. And we went from the circle with its radius transforming or rotating around it to what that looks like, which is this is not going to work. It's not going to be a triangle wave. How do we get this? We run processing. We see this sinusoidal wave. And that sinusoidal wave broadly mirrors the sinusoid of a longitudinal wave, which is the molecules of air transferring energy backwards and forwards from my voice to this microphone. So I demonstrated that, and in our circle I said that the point here at the end of the sine wave, and how can we do this? Well, we can actually make a sine wave. I'll go to Excel, so I've launched Excel. I'm going to make a number sequence in degrees starting at 0, and I'm going to fill that with a series in the column with a step value of 15 degrees to 360 degrees. Now we know that when you look at a calculator, you see here degrees, and you see this other one here when you click radians. Now we need to be working in radians to make this work. And to convert from degrees to radians, we do a mathematical calculation, and that always begins in Excel with equals. And if I type R, all the functions beginning with R appear. Double click radians. It opens the brackets for me, and I just put my column A1. and now I can get it to fill in all of them. And what I was going to point out is that if we have a sine wave, and why can't I freely draw it here? Let me see whether I can actually draw it at a tablet thing without drawing just a straight line. I need a normal pen. Here goes. This could go horribly wrong. It's drawing me a... No, I want freehand. How do I get a freehand pen? There's a freehand pen. So let's try again. This is 2 pi. This is pi. This is 3 pi over 2, and this would be pi over 2. Because this is a radius going around an angle, and it's travelled that circumference of the circle, which we said the circumference of the circle was 2 pi. So it's done the circumference of the circle in 2 pi radians. And here is our pi, 3.14 at 180 degrees, and here is our 2 pi at the end of the circle. So now we can do a sum and get the sine of B1. And now we can plot that by going insert, chart, scatter graph. And it lists our sample number and our sinusoid over 25 individual samples. So the interesting thing is we could get Excel to make a sinusoid of 8,000 samples. So finally in the class what I talked about was the fact that if this was the time axis and this was amplitude, then we could quickly move from let's say y of t equals, well, we'll always be scaling by our amplitude, but that's going to be 1 for now, so we can disregard that, times sine of 2 pi times our frequency times a time point. Now we went through some examples of the time point, but what I'm going to do now is if this is y at a sample number small n, then we do small n over our sample rate, a number of samples, plus theta. Now theta is the phase offset, and we're assuming that all the time our sine waves start here, but maybe it starts here, and that would be an offset, and that's offset in radians. But we're not going to worry about that, and we're not going to worry about that. So we're just doing sine 2 pi times the frequency, sample number divided by the sample rate. Let's do that in Excel. Be nice to get rid of that chart. Okay, maybe that's not going to happen. Let me do a new one of those. And let me get rid of that one. Obviously, we also did Bach, Beethoven, Amy Beach, and another female composer, Kaya Sariaho. And let's say 4 people like him, 5 people like him, 3 people like her, 2 people like her. And we did a scatter, not a scatter chart, a pie chart to represent percentages, looking at how you could use it for graphics if you were doing something to do with music psychology, say, or any representation of data. So we're going to do a 0 and then a fill of a series in columns, stopping at 8,000. And then in this column we are going to do equals 2 the sine of 2 times pi times our column number, our sample number, divided by our sample rate, times our frequency. Let's have a frequency of 440 cycles a second, and divided by our final sample rate, which is 8,000 samples. Found a typo in your formula. Okay, let's do it again. Where there's a double brackets end, divided by, divided by, open bracket, pi, close bracket 1, close bracket 2. There we go. And now we select the whole of the column, we do a fill, we do the series, and we get it to autofill. Scroll down to 8,000. Select that. Actually, what we could do is now go down here. I don't know why it puts this many numbers in. Clear contents. Select here. Go up to the top. Copy all that. Find a temporary place and make a new text document. Paste those numbers in. Save that. Launch Audacity. And Audacity has the ability, you'll never use this, but it has the ability to load sample data import, which means any data you like can be loaded. And we've got on my desktop somewhere, my desktop, here it is, new text document. Okay. And I made a mistake because my project sample rate, and I talk about sample rates in bit depth, I'll go over those in another class. Again, I set it to the wrong sample rate. Let me just set the project to 8,000 sample rate. Tools, sample data import, same file, and there we have a second of a sine wave. And it sounds like this. And that is more than enough to keep you going, but that's what we, broadly speaking, covered in the hour of the class. There's a link. We did the sine in Excel, we did the sine to audio in Audacity, we looked at the sine from the circle. I hope that helps.